today, for 5 day 2, we're going to be using all of those inverse rules. 5 day 2. So make sure your blue sheet is completely filled in with all of the trig derivative rules and all of the inverse trig derivative rules. Okay, so just examples today. Some are easy, some are challenging. We'll start easy. F of x equals inverse sine of 2x. And you really should have your blue sheet next to you so you can look back, because I can't get both of them under here at the same time. But inverse sine, the derivative rule is 1 over the square root of 1 minus the u, and all of that 2x is that u squared. So I'm just going to take the time to square both parts of it now, so that'll be 4x squared. And then all of this is times u prime, and the derivative of this is a 2. So really all I need to do is slide the 2 on the top, and it's good to go. 1 minus 4x squared. Number 2, let me challenge you a little bit more. F of x equals 3 times inverse cosine of x over 2. And remember that x over 2, that's just another way to say 1/2 x. So derivative of inverse cosine is -1. Remember, if it starts with the c, it's got the negative derivative. Square root of 1 minus u squared. I'm actually going to square this one to keep it a single fraction. That's going to be x squared over 4. And all of that's under the square root times u prime. Easier to see the derivative here. U prime is going to be 1/2. Okay, would be nice if we could leave this, but we've got a fraction down in the bottom of this fraction. We're going to simplify that. So calculus is done, algebra is going to take over. So the way we're going to simplify that is to turn this into a single fraction under here. So I'm going to turn the 1 into 4 over 4. That's equal to 1, and so that I can make a single fraction here. So I'll have -1 over, I'm going to slide the 2 over in front of the square root. And in here I'm going to have 4 minus x squared all over 4. Remember, that whole thing is under the square root. Now I'm at a spot where I can take the square root of the top and the square root of the bottom separately. I think I'm going to move this way. I'll go down. -1 over 2 square root of the top over square root of the bottom. And now what happens here, think of that as 2 over 1. Square root of 4 is a 2. That can cancel that. That got rid of our fraction in the bottom, and that will happen on these. And there's our final derivative. So when your ratio ends up being a fraction, it's a little more work to simplify it. Let's see, I think I can fit this one on here. Number 3, f of x equals inverse tangent of 3x to the 1/2. So following the tangent, inverse tangent derivative, we'll have 1 over 1 plus, this is the u, and that needs to get squared. For this one, I think I will put it in parentheses. 3x to the 1/2 squared, and then times the derivative of the u. Well, that's a little power rule. The 1/2 gets multiplied by the 3, so that'll be 3/2 times x to the 1 less power, that's going to be -1/2. Okay, simplifying. In the numerator, I'm going to have the 3. This has a negative exponent. I am going to make it happy and bring it to the bottom. So the only thing I'll have in the numerator is a 3. In the denominator, I've got this quantity 1 plus, squaring this, I've got to square the 3. That turns into a 9. And to square the x to the 1/2, we multiply exponents. So that will become x to the first. In the denominator, the 2 is in the denominator. Usually write that at the front. And then the x to the negative 1/2, that was up in the top, I'm going to kick down and make x to the 1/2. And that's it. As far as that goes. Number 4. These are quick. G of x equals inverse cosine of x squared. Okay, so we've got a chain rule where we have an inside to a power. So we're going to follow our chain rule, and when we get to the inside, we're going to follow the inverse derivative. So we're never going to forget any of those rules at the top of your sheet either. They just keep sneaking in here. So chain rule first. 2 comes down times the inside to the 1 less power. That'll be to the first. So I really don't even need the parentheses anymore. Now times the inside derivative, that's an inverse cosine. Looking on my sheet, that derivative is a negative 1 over square root of 1 minus the u, which is just an x, squared, times the derivative of x, which is just 1. So here, not much to simplify here. The negative comes to the front. So negative 2 inverse cosine of x all over the square root of 1 minus x squared. And the toughest one of them all, the secant and cosecant with a fraction. So here y equals inverse cosecant of x over 10. Remember, you can think of that as 1/10 x. Either one works. I'd like to look at both of them. So derivative. Inverse cosecant. Here we go. Right here. Negative 1 over u squared. This is the u. So I'm going to square the x and the 10. Oh, I'm looking at the wrong one. That's cotangent. I lied. Cosecant's back here. Let's see. Negative 1 over its absolute value of u. Absolute value of x over 10. Then a square root. Forget that. Square root of u squared. That's x squared over 100. Squaring both of them. Minus 1. All times the derivative of the u. Here it's easier to see. The derivative is 1/10. Okay, now the simplifying. We have to get rid of this fraction within the fraction here. First thing we're going to do is get a common denominator and make this 100 over 100. Okay, so let's see. In the numerator, I'm just going to have a negative 1. Here, I'm going to keep that absolute value of x. And remember, that's a 1/10. I can take the absolute value of 1/10 out, or just over 10. I guess I'll put it over 10. That's good enough. Then I've got the square root of x squared minus 100 all over 100. And then this 10 times by 10, because there's fractions here, I'm just going to put it over 1 so I can keep everything straight. My fractions within fractions need to be lined up so I can see what's going to cancel. Well, by doing that, I can now easily see that these 10's go away. That was easy to see. Here I can now take the square root of the top and bottom separately. So -1 over absolute value of x. I'll have the square root of x squared minus 100 all over square root of 100. Square root of 100 is actually just a 10. Hold on, let me get rid of that stuff on my computer. So this I can just rewrite as a 10. So now think about this. I could extend that over 1. Think about this as -1 divided by this ugly fraction. Well, this ugly fraction, I would flip it over and multiply it by the top. If you can see it all, what's going to happen is that 10 is going to come to the top, get multiplied by the -1, and then the absolute value of x, square root of x squared minus 100 is going to stay in the bottom. Okay, if you didn't follow that, I'll try it one more time. Think of this as -1 over 1, that fraction, divided by this fraction that has absolute value of x, square root, all over 10. This bottom one's going to get flipped over and get multiplied. So there's my -1 over 1. Flip this one over, the 10 comes to the top. That absolute value of x, square root of x squared minus 100 is in the bottom, and then you can see I've got my answer there. So hopefully you could follow that. It's just a fraction divided by another fraction, and you flip and multiply. Okay, last one's a story problem that I'll start for you when you finish in the homework. It is so it's example 6, but it is number 25 in your book. And they give you a picture. I'll just refer to it real quick like. You've got a patrol car sitting 100 feet from the perpendicular side of the highway. And he observes the truck approaching. So at a particular instant t, some time value in seconds, the truck is x feet down the highway. The line of sight to the truck and that perpendicular line, they're calling the angle theta. It says explain why theta equals the inverse tangent of x over 100. So I'm going to rewrite that triangle and work on the problem here. So here's our truck. Here's our distance x. Here's the cop. This is 100 feet off the road. Oops. This angle is theta. So they want us to write an equation involving, not theta prime, theta. Well, if we're standing on theta, I've got opposite and adjacent. That's a tangent problem. So the tangent of theta will equal opposite over adjacent, x over 100. To solve this for theta, because their equation said solve it for theta, I need to get rid of the tangent. The way I do that is I do the inverse tangent on both sides. So the inverse tangent on both sides lets those cancel. So theta equals the inverse tangent of x over 100. That's part A, just